Hello. What we are going to do for the last part of the course, I'm going to take some sections from chapter 10. We start with the 10.3. In case you want to take calculus 3, you have to know some idea of the what's going to be the one we call it polar coordinate system. You may have seen the polar coordinate system in your pre-calculus classes. But we're going to give you the introduction of the kind of function in polar form. Then briefly we talk about graph of these equations in polar form. Then we are going to check the type of application problem that you have. You are going to use the idea of the arc length. Okay, we want to see what is going to be the arc length in the polar form. And then there is use integral in calculus 1 in order to find the area under the curve. You can do all these in polar form if you like. If you take calculus 3, so you are going to have a three-dimensional system and your integration would be called triple integrals. But in order to find those integrals, you can use the idea of the polar coordinates. Over there, they are going to explain it again, but not going to be in details that we are going to do it now. Okay, so sometimes we don't cover it, we won't get time, but I would like to give you just a brief idea before the final exam, because you're done with your quiz 4. I will post the final review for you, and then we review and get to the final. Okay, so let's see how far we can go. It just is not bad to see an idea, then you are not going to be surprised, and even maybe some of you are not going to take calculus 3. So why not? It would be a bonus to have an idea of because we talk about integration in different format. So how about integration in polar form? Because most of the curve are going to be easier to handle if you are going to use this type of new system that we're going to have. Okay, so let's get some preliminaries first, okay, to remind you how this new system is working, and then we bring those 3 concepts of the integrations that we are going to be interested in. Okay, so I think it's a 10.3. I briefly put them together, the one that we need. 10.1, 2, they talk about parametric equations. They are going to see it in calculus 3. So what is going to be polar coordinates? Okay, so what is polar coordinates? You know that you already got the one XY coordinate, or Cartesian or rectangular coordinates. So in rectangular coordinate, you identify each point by X and Y, and you consider the distance, horizontal one and the vertical one. In application in science, they don't like this version of the distance. They like to express things in terms of angles, okay? In physics, engineering, because that help us to be able to do the operation easier. So what's going to be the polar coordinate? You see, the polar coordinate consists of, let me write it down. Okay, so this polar coordinate, it consists, a system consists of a fixed point. Okay, consists of a fixed point, the origin, fixed point O, called, we're going to call it the pole. Okay, we call it the pole, or just or origin, but I prefer the pole, or the origin, and a ray, a line. Okay, the ray that's going to be coming, emitting, coming from the origin, from the pole, from the pole. This line is going to be called the polar axis. polar. Okay, polar axis. So this is the situation you're going to have. You see, you start with the point here. That's the point O, which is the pole or the origin. It's going to be the origin like the x-axis that we have. You see, take this one, this line or ray. This is going to be your polar. Okay, this is going to be your polar axis. Okay, polar axis. Now, how are we going to identify a point over here? You see, the point would be identified by an angle. You see, if this is going to be the one. If you be given a point P, so your point P would be denoted by R and theta. Now it's going to be this. Okay, you start from here and you pick the angle theta. So this is going to be the angle theta. Then from the origin, you are going to pick the R. So if you just pick the R, if this is going to be, you see, this is going to be the R. So this point P would be represented by R and theta. Okay, R and theta. So it's like going around the circle. Okay, you can imagine that you are going to have the origin would be the center of a circle and with the radius R, and this point is going to be on that circle. Okay, so you can have that the direction like the trigonometric one, counterclockwise, would be considered the positive direction for the data, or you can have a negative direction. So let's identify some points to see how we're going to work with this system. So for example, if you have the point P is going to be equal to the 6 and 45 degrees, okay, or you can talk about in radian, is going to be pi 4. So if you want to identify this point, this is going to be the case. You see, get the origin, and this is going to be the pole. So you pick the end, you pick the 45 degrees here, and then you just pick 6 units. Okay, 1, 2, 3, 4, 5, 6. So this point would be represented by 6 and 45 degrees. Okay, this is the way you are going to locate these points that you are going to have. Okay, call this one number 1. And number 2, you can have something like, the point P would be represented by 5 and 120 degrees. The same thing. So this is going to be the 1, get the 120. So this is going to be 120 degrees. And you pick the R here. Okay, 5 units. For example, this is 5. If this is going to be the 5, so this point would be represented, point P would be represented by 5 and 120, 120 degrees. Okay, so different formats, you can go around the circle. So the next point is going to be something like 3 and 225 degrees. It's over 80, over 180. So you get the pole. This is going to be the pole. So you want to pick the angle, so you have to go on. Okay, this is going to be 90 degrees, 180 degrees. So this is going to be, you see, this angle is 225. So you pick the R in this direction now. And this is going to be 3 units. 1, 2, 3. So this point would be represented by 3 and 225. Okay, so you pick the R as in the direction of, okay, this is going to be kind of a terminal size of your angle. So when it's a terminal size, and you pick the R here to get to the point. Okay, so it can be, you can be in the first quadrant if you like, the second, the third, the fourth. For example, you can have this point. If you have the point which is going to be 4 and 330 degrees. Okay, so this is going to be the case. So it's nearly 360. So you go around, okay, so you are going to be here almost. So this angle would be represented by 330 degrees, and in this direction you pick the 4 units, 1, 2, 3, 4. So this point would be 4 and 330 degrees. Okay, so these are going to be the case. You can have negative angles, you can have negative R. Okay, so just give you a couple of more example to see how we're going to identify these numbers. Okay, so let's have something like number 4. See, for number 4, you may have 2 points because you go around the circle. So you may have 2 points. Look at these points. Suppose the point P is 1 and 315 degrees, and other point Q is going to be 1 and negative 45 degrees. Let's see how we're going to identify these. Okay, so this first one, 315 degrees. So this is it. So this is going to be the pole, and then you go around. Okay, so it's going to be here, 315. Okay, in this direction, and you pick that you're on 1 unit. Suppose this is going to be 1. So the point P is 1 and 315 degrees. Now, if you pick the other one, so what's going to be the other one? Let's say this is the one. Negative 45, you pick the angle, you go in this direction. See, if we go up in that direction, the angle would be positive. The other one would be negative. So you have to pick the angle in this direction. So this is going to be negative 45. And then you identify the 1. That's it, the 1. So that would give you exactly the same point. So you see this one over here, you can read it as 1 and 315. So if you go from this direction, that would also represent negative 45 degrees. Okay, so because this is going around the circle, the way they do this graphing one, or you can check it when you get the graphing, we explain it. But today, you can use your calculator to get these numbers. But sorry. See, this is going to be a kind of graphing version that we usually use for this. So look at this one. These are going to be the circle. All of them are centered at the origin. Okay, centered at the origin. And these are going to be the angles that you need. Okay, and if you want to identify any points, for example, the last one that we did, 315. So you check 315 here, you see that's a 315 degrees. So the angle is here. Then you can pick the numbers. You see the numbers over here. This is going to be 1, 2, 3, 4, 5, 6, 7 units. So quickly we identify it. And for the negative 45, you are done. You see that was the one. Then if you want to get the negative 45, so you start from the 0, and then you get to the negative 45, which is here, and that gives you the same thing. Okay, so when it's a face-to-face, I usually make a copy of this paper and hand it out, and on the test, on the quiz, I usually ask to graph it using this one. But since it's not a face-to-face, I cannot do that, but I just let you know that these type of devices are available. They are all online. Search on internet for the polar coordinates. You will see them quite a lot. So if you need, you can print it for yourself. Okay, but this is it. I'm going to get back to it when I want to graph a function type for you. Okay, so this is the new system that we have. So this new system, the point would be identified by measurements R and the angle data over here. Oh, I didn't give you anything for the negative r. See, r in general is a distance, but in the polar coordinates, r can be also a negative number. So the absolute value is a distance, not that r. Okay, so for example, if you've been asked to identify this point, let's say the point -3 and 45 degrees. If you want to identify this one, this is going to be the case. So your angle is positive, so we get a 45 here. So this is the 45 degrees. You see, if r is positive, you pick the numbers in this direction. But in this case, the r is negative, so you are not going to pick it in this direction. So you continue this one as a dot line, and then you pick the 3 units here. You see 1, 2, 3. So this point would represent the P, which is going to be -3 and 45 degrees. Okay, so when R is positive, you pick it in this direction of the angle in the terminal side. If R is going to be negative, you have to go to the other side, okay, because it's like a +3 and the -3, if you think about this line as the horizontal line. Okay, so this is going to be the situation for the identify the points. Now, so we have two different systems, XY coordinate and the polar coordinate. So you must know the relationship between these two. Sometimes it would be easier to go from one to the other one. So what is going to be relationship? Okay, relationship between polar and rectangular coordinate and rectangular coordinates. You need them, you know, when we get to the integrations. So the situation that we're going to have is going to be, you see, if you consider a point, if this is going to be, see if this is going to be the XY system that we have, and then if you pick a point to see if this is going to be X, and suppose this is going to be Y. So the point P is here. The point is P is here in the XY coordinate. So this is going to be X comma Y. But if you want to change it to the polar coordinates, you see, you can draw this line. That would be the R. Okay, so this is going to be R. This angle over here is going to be our data. So we can find a relationship nicely. See, this is a right triangle. And so this is it. X is going to be equal to, okay, you can find the cosine of the data because the X is adjacent. Is going to be X over R, or X would be R cosine of data. And the Y would be R sine of the data. We are going to use this formula quite a lot. Just make sure to remember it. Okay. So if you give me R and data, I just substitute, get the X and the Y coordinates. But the other one is R is in this right triangle. So R is R squared, if you like. It's equal to the X squared plus Y squared. So if you give me X and Y, I can find the R quickly. And then I can get the data by using this idea that the tangent of the data is going to be Y over X. You see? So that would be very useful. You know, going from one to the other one. Okay. So if the point is given to you in polar coordinates, so you have the R and the data. You substitute here, you get X and the Y. If X and the Y is given to you, you can use this formula to change it to the, okay, change from the, okay, changing from the XY coordinate to the polar coordinates. Okay, so from time to time we do it in calculus 3 quite a lot. And you have some problems in your book, like say, we are not going to give, of course, this type of question test, but this is part of the deal that we have to know it. So for example, if you want to convert a point, convert a 6, 2 by third, okay, into rectangular system, into rectangular coordinates. Okay, so what we're going to do, we are going to call this point P. You see, it's in polar form, so R and the data is given to you, which is a 6 and 2 by third. So your job is you want to change it to the X and comma Y. Okay, you compare them together. So in this case, you do have the R is equal to 6, and you have the data, which is equal to the 2 by third. So you want to find the X and the Y, there you are. X is R cosine of the data, and Y is R sine of the data. So we write the formula, substitute. X would be R cosine of data. So the R is 6, cosine of the 2 by third. Cosine of 2 by third is going to be negative half. So the result would be a negative 3. So that would be the X. Okay, for the Y is R sine of the data. So R is equal to the 6, and this is going to be the sine of the 2 by third. And if you check the unit circle, that's a radical 3 half. And you simplify it, that gives you 3 radical 3. Okay, so the point in question, this is it. So you have the 6 comma 2 by third. Now this is going to be equal to, okay, your polar coordinate would be negative 3, and okay, so this is a point in polar. So the point in XY coordinate is simply going to be negative 3 comma 3 radical 3. Okay, this is the way you are going to go from one system, to the other ones. Okay, so the polar was given, we change it to the coordinates. Okay, let's have another one. Let's have the other way around. So how about if okay, that was the conversion from polar to the XY coordinate. Easy, you have the formula, substitute, you get it. The other way around, if a point is given to you, you see, if you have the XY coordinate you want to change, okay, so convert, okay, for example, we're going to convert these points, 2 radical 3 comma negative 2, okay, into polar coordinate or polar form, polar coordinates. Okay, converted to the polar coordinates. So the solution is going to be, so you have the point P in XY coordinate now, X comma Y, and that gives you 2 radical 3 and negative 2. So in this case, you do have the X, so the X would be 2 radical 3, and the Y would be a negative 2. Okay, negative 2. So what you have to do, you have to find the R, and you have to find the data. R is easy, because R squared is X squared plus Y squared. Okay, X squared plus Y squared. And the thing is going to be, okay, this is it. So that gives you 2 radical 3 squared, okay, plus a negative 2 squared. So radical 3 squared would be 3, 2 squared 4, that gives you 12, plus 4, which is 16. So R squared is equal to the 16. So we have 2 possibilities for the R. You may get a positive or negative 4. Okay, sometimes some restriction would be given to you. then you pick the one that they talk about it. If R is positive, you pick the R equal to the 4. Okay, so this is going to be the first one. Then we can decide which one is going to be the case. Okay, so we assume the R is positive, and then R would be 4. Okay, so for the data, you have to go with the tangent of the data. Tangent of the data would be y over x. Okay, the y is a -2, and the x is 2 radical 3. Okay, so this is going to be the case. So you simplify these two, so that give a -1 over radical 3, and you rationalize it, that give a radical 3 over 3. So the tangent of the data is equal to the negative radical 3 over 3. Okay, this is going to be the one. Now you have to decide where is this data that you're going to have. Okay, that would be important to find out. So you check the point. You see the point given to you. X is positive, y is negative. You see x positive, y negative. So this means the point is here. Okay, the point is going to be here. So you have to pick something that corresponds to this, to this point that you have. So you know that the radical 3 over 3 is going to be, this is going to be the tangent of the 30 degrees. 30 degrees, if you want to be here, so it's going to be 360 minus 30. Okay, so this is going to be, the point is going to be 330 degrees. Okay, or in radian is going to be 11 pi 6. Okay, so it depends on the position of that point. You got to be careful to just look at the point to see where the point is. You see the point is going to be here because the x is positive, y is positive. So as you can see, 330 degrees, you see it got over here. And then this is going to be the line that you have. Okay, you can pick the R equal to the 4. So it's going to be R equal to 4. And that would be the point in question. Okay, so the point in question is going to be R 4 and 11 pi 6. You see, the difficulty is that this point is not going to be unique because I picked the R to be positive. I know just the 4 here. So I can have the R to be negative. Then if R is going to be negative, then I have to check it on the other side. So if some restriction would be given, then you just pick one of these numbers. As we go on, those restrictions would be identified when you go to different problems. But if you haven't done this type of ideas in pre-calculus, okay, just check your book. Okay, check the 10-3 to get more information. But it's going to be a straightforward really, because we would like to get to the function part of this. Okay, that's the one that we are going to be interested in. Okay, so this is going to be the system that we have. Now the question is going to be, we want to quickly, so this is a kind of okay system that we have. The function that we defined before, you see, the function is what? Y equal to the f of x, and we did have some condition for the function. The definition of a function is that for each value of x, you can get only one value for y, such that y would be equal to the f of x. So with those type of ideas for the function, I'm not going to have such a function in polar form, if you like. So we're going to have a kind of equation. You have the equation in x and the y in the coordinate system. Now we are going to have the equation in r and theta. Okay, so your function is originally in that xy coordinate that you did. So when we get that equation, okay, then that equation can have various possibilities. Okay, that equation can have can have a graph, okay? Because X and Y, so you can graph a function in XY coordinate. So how about when you change it to the, okay, polar coordinate, which is going to be R and theta. So we're going to talk about the graph of an equation, not a function. An equation which is going to be given to you in R and theta. Because this is what we are going to do, because we are going to change. If the function is given to you, okay, then we change that function, we switch it from the XY coordinate into this new form of the R and the theta, then you should be able to talk about continuity, differentiability, integrability, all these type of ideas, okay? So let's see how we're going to look at the graph in polar form. Again, you may have seen it before. So how about graphing? Graphing a polar equation. Just briefly give you the idea. What does it mean, so that we be able to take at least one part of the calculus. Okay, version now. Okay, so what's this? You see an equation. So an equation like R equal to the f of data. So this would be in polar form. Okay, your variable was X and the Y. We change it, we get to this equation. Okay, whose variables? Okay, whose variables? You cannot say function because they are not function. Okay, whose variables are polar coordinates. Okay, polar coordinates is going to be called, okay, it's called a polar equation. A polar equation. It's equation R and theta. Now the graph of these equations, the graph of this, okay, the graph of this equation is going to be the set of points, as usual, the set of all points with the coordinate of R and theta, for which, okay, for which at least one of those, one of the polar coordinate, the polar coordinate representations, okay, representation satisfies the equation. Satisfies the equation. Let's see, what does it mean? You see, when you write y equal to the x squared, you see y equal to the x squared, you know it. When you want to graph it, the graph is a parabola. So the graph is a collection of points that satisfy, is a collection of points x and the y that satisfy y equal to the x squared. Okay, but in the case of the polar equation, so this is going to be a collection of points. The points, the coordinate would be R and the data. But as I talk about it, because of those angles that you saw, you see if you get the angle of the pi 4, you go around the circle 2 pi, and then you come back again to the pi 4. So you can go around twice, 3 times, 4 times, 5 times. So this is not going to be in a sense of the function that we know it. So each point may be each coordinate. Each coordinate can represent many, many points, because you go around the circle and you arrive at the same point. So when we want to graph the function, we say, oh, this is going to be the graph of all the points of the coordinate R and the data in which, yes, those points are going to be on the graph. At least one of them are going to be on the graph, okay? Because they are going to be represented various points. So if you have, we talk about 4 and 45, this can be 4 and 45, or it can be 4 and 45 plus 2 pi, 360, 4 and, just going around that. We know what we are talking about. It's going to be a collection of points. And we know that this is not going to be a function, it's going to be just an equation. So we are going to identify some famous one that we are going to use, okay, and to give an idea of how we behave or how they behave. So let's see some popular one. We want to identify the each graph. Okay, identify and graph each graph each polar equation. Okay, so the first one on the list is this one. You see, the first one is r equal to 3. There is no data here, so it means the data is free. So r equal to 3 and the 0 angle. R equal to 3, pi 4, pi 6, pi third, etc. Okay, so if you look at the chart that I gave you, you see, if I look at this one that I gave you over here, you see over here, so R is going to be fixed. You see, you can fix the R, one of these radius, one of this circle. You see, if you just fix the R was equal to 3. This is 3. So R equal to 3 is going to be this circle. Is a circle that's going to be centered. It's going to be a circle that's centered at 0 with a radius of 3. So as you can see, you can have many angle data. So if you pick a point here, you see, if you pick a point here, for that point, R is equal to 3 because it's on the circle, but the angle is 15 degrees. So we can pick another one, 30 degrees, etc. Okay, so this equation, okay, R equal to 3 is going to be the graph of this equation. It's going to be a circle. It's going to be a circle centered at 0 with radius 3. Okay, so this is it. So that's going to be center, radius 3. You see 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So this is going to be the graph of this function. You can pick any data you like. Okay, so the graph of the equation, the graph of this equation is a circle. It's going to be a circle centered. It's going to be a circle centered at the pole, if you like, the origin. At the pole with what? With radius 3. So this is going to be the one. Quickly we find out. Okay, you don't need it, but if you need more to understand, some people they say, "Oh, I'm going to change it to the XY coordinate so I can see it." If you want to do that one, you see this is R equal to 3. If you square that, give R square equal to the 9. But remember, R square is x square plus y square. X square plus y square equal to the 9. You know that this is the equation of a circle. It's going to be a circle centered at 0 and the radius of 3. So different version to understand. Okay, so this is going to be one of them. So we have R equal to 3, R equal to 2, 5, 6. It's just an equation of a circle. Okay, let's have another one. Let's give you so most popular one. The next one is data You see, data equal to the pi 4. You see, for this one, we fix the angle. If you fix the angle, okay, the angle is going to be just pi 4. You see, this is what you have. This is the one. So this is the angle. The angle is pi 4. You fix the angle, but you free the r. So what is r? We talk about it. R can be any number here. R can be any number here if r is going to be positive. And if r is going to be negative, so you can pick some number here. So if you pick the 1 here, that would be 1 and pi 4. If you get the 2, 2 and the pi 4. If you get the -1, -1 and the pi 4. So in this case, as you can see, the graph of the function is going to be simply a line. It's going to be a line, okay, passing through the origin and making an angle of the pi 4. Okay, so that's easy. So the graph is just a straight line. The graph is a line. It's going to be a line containing the origin or the pole, containing the pole. Okay, containing one pole, making an angle of 45, angle of 45 degrees, or the pi 4, or pi 4 with the polar axis, with the polar axis. Okay, so this is going to be 1. Again, if you are going to be more picky, say, oh, okay, there you are. You don't like it, I just give you more proof. Remember, note that the tangent of the data, we talk about it, is y over x. But the data is pi 4, so that gives you the tangent of the pi 4 is equal to the y over x. But you know that the tangent of the pi 4 is 1. So 1 equal to the y over x, so that gives you y equal to the x. That's it. And you know that y equal to the x is what? Y equal to the x is the line passing through the origin. That's exactly what we predicted here. Okay, so these are just we try to give you a better idea, or you must get a better idea of how this system would work. Okay, so these are going to be the special one. Okay, r equal to 3 and the data free, we get a circle. Data fix, r free, we get a line. Now this next one is a very popular one that we are going to use, and you must know it. Number 3. Number 3, r equal to, r equal to the 4 sine of the data. This is the kind that you will see in calculus 3 quite a lot. You should be able to identify it quickly. As soon as you have a look, you should tell us what type of graph is this one. Okay, now if you do a Libre algebra, then we find out, then you can memorize it and use it anytime you like. So look at this one. What I'm going to do, I'm going to try to change it into the, okay, you don't have to, but I'm going to change it into the polar form first, XY coordinate first. Okay, so what I do is going to be, again, this is r equal to the 4 sine of the data. I want to change it to the XY coordinate. So remember, X was R cosine of the data and the Y was R sine of the data. I multiply this by R. If I multiply by R, that gives me R squared, and that's going to be 4R sine of the data. Okay, now you substitute. You see, I'm going to substitute for this one, R sine of the data. I put the Y for this one, and for the R squared is X squared plus Y squared. So I get the X squared plus Y squared, which is equal to the 4Y. You know that this is a circle. So you move the Y to the other side. That is going to be the case. and use completing the square method, remember. So it's going to be y, you divide this one by 2, y minus 2 squared, minus 2 squared, which is 4, equal to the 0. So that gives you x squared plus y minus 2 squared, which is equal to, okay, equal to 4. As you can see, this is going to be a circle. It's centered at 0 and 2 with the radius 2. So this is going to be your circle. So the center, this is the center, and the radius is 2. So going to the right, to the left, 2, 2, 2. So that gives you the graph of the function of the equation. Okay, so the graph of the equation. Okay, the graph of the equation is simply what is a circle. It's going to be a circle centered. It's going to be a circle centered at 0, 2 with the radius. Okay, with the radius 2 to get these numbers. Okay, you get these numbers right there, right away. Okay, so this is going to be one group. If you have a number, just time sine of the data or the cosine of the data, you must know that the result automatically, you must know it. You must know that the result is going to be simply a circle. Okay, a circle, and if you need it, you can graph it. Okay, graph it right away. There are different ways to, but this is the easiest way to graph it. You can also get some numbers, okay, and you do it on the polar coordinates. Okay, pick some number for the data, and to get these numbers, you see, books. You can pick the 0 and you can pick the pi half and make a chart, and then do it. But this is not difficult. I can do it for you so that you can see it. You see, if you don't like, but we wanted to identify it for us. But otherwise, this is it. You get the idea of what's going on. So this is going to be the data and the R. So you pick some numbers, you pick the data equal to the 0, sine of the 0 would be 0. Okay, and then the crucial one, if you get the pi half, okay, the pi half, the sine of the pi half is 1, so that give you 4. Okay, then the other one is going to be if you pick the pi, so we're going to be 0, pi half, pi, so we get the 0 again. Okay, then you get the 3 pi half, like in trigonometric one when you want to graph this one. So that gives you a negative 4. And if you pick it to 2 pi, so that gives you a 0 again. That's exactly when you graph this function in the just usual trigonometric function, because the period of the sine is 2 pi. Remember, we divide to 4 parts to get these numbers right away. So you can use these papers or just read yourself, okay, to get these numbers. You have to identify this point 0, 0. Okay, I show you here. So this is going to be 0, 0. So this is one point that we have. Then you have the pi half and the 4. So this is going to be pi half 4. You get a 4 unit here. You see 1, 2, 3, 4. So this is going to be the next point that you have. So you have to go from here. You see, you have to go from here to that part, and you can pick some numbers in between. Okay, and then you go to the pi, that give you 0. So this is going to be the pi. So that would be 0. This means you're just coming back, if you like. Okay, so you know, if we the numbers is coming back, and if you go with the 3 pi half that give that 3 pi half that give a -4, so this is a 3 pi half -4. Remember, in this is the 3 pi half -4. You just take it in the opposite direction. Remember the opposite direction that we have. This is a 3 pi half. You're not going to pick it in this side, your opposite direction, that take you back to the here. And therefore the 2 pi is going to be 0 again. So you know, you need more points, but this is going to be a kind of situation that you are going to have. Okay, we get the circle again, and it can be done if you pick more points. Okay, so if you even if you want to do it here, you see these are going to be the case. So the 0, 0 is here, 0, 0 here. If you want something in between, you can pick something nice. Okay, so for example, if you pick the, what is nice for the sign? If you pick the pi 6, sine of the pi 6 is 1/2, so that give you 4 times 1/2, which is equal to 2. So if this is going to be, okay, if this is going to be pi 6, 30 degrees, so you pick 1, 2. That give you 1 point here. Then if you go to the pi half, this is going to be pi half, you get a 4. So it's going to be 1, 2, 3, 4. You see, so you start with a 0. Okay, this is it. And then the pi give you 0. Okay, and you can pick more points. Okay, you can pick 100 and, okay, 150 degrees, which is going to be 5 by 6. The 5 by 6, the sign is going to be the same one, so that give you the same number. And the pi that give you 0. So you're going down and you get this one right away. Okay, different cases, but because this can be done by, you know, by a calculator, but you must know the shape of the graph. The shape of the graph is going to be, you see, if you get a sine or the cosine, the shape is going to be a circle. Okay, so in general, R equal to the A sine of the theta, or R equal to the A cosine of the theta, okay, represent circles. Okay, so this is going to be one version. Okay, so that's one. The next one is very important, and we are going to use it quite a lot. So we want to know it. So that's number 4. Number 4 is this: R equal to the 1 minus sine of the theta. It can be 1 minus sine of the theta, or it can be 1 plus or minus, or sine of the theta, or the cosine of the theta. Okay. Now, if you want to graph this one right away, so you need to collect some points, some nice points to be able to identify it. I do a couple of them for you here. Then we give you the shape of the graph, and then you can memorize the shape of the graph and use it later on. Okay, so if you want to collect some points, this is it. Depends on the period of the sine function, which is 0 and 2 pi. So I'm going to pick some nice number in between. So that's the theta, and this is going to be R1 minus sine. Again, graphing calculator or calculator will give us the result right away. So if you pick the theta equal to the 0, sine of the 0 is 0, so that gives you 1. If you pick the pi 6, some nice number. So the pi 6, the sine of the pi 6, 1/2. 1 minus 1/2 would be 1/2. If you pick the pi half, so the sine of the pi half is 1. 1 minus 1 would be 0. Okay, if you get the 150 degrees, because the sine is 1/2 again. So that give you 1/2 again. Okay, and if you pick the pi, that give you 1. Okay, so as you can see, we start with the 0, 1, and we end up with the p and pi and 1. So continue again, just add the 30 degrees to make it easy. So the next one is going to be 7 pi 6, which is 210. So the sign is negative, 1 plus 1/2 would be 3/2. And then another one, so that give it 3 pi half, 270. For the 270, the sign is negative 1, that give you 2. And eventually we get to the 2, another one, another 30 degrees, make it to the 11 pi 6, 330, that give you 3/2 again. And for the 2 pi, you get 1. When you know it, we just get less points. But you don't know it now. That's why I give you these points. So I can use the graphing paper to graph it, but I'm going to show you here how I'm going to do it so that you get the idea of this graph. Okay, so let's have a polar coordinates. So this is going to be the case that I have. Can you see it? No, it's not good. Okay, so I go with this one. So the starting point is going to be 0, 1. Okay, x equal to the 0, 1. That's going to be 0, 1. So suppose this is 1. So we start with the 0 and end up with the 1. So this is going to be your first point. Then you go to the pi 6. So I'm going to identify the pi 6, 30 degrees. Suppose this is going to be pi 6. So that would represent the pi 6. And over here is going to be 180 plus 30, which is going to be 210, 7 pi 6. Okay. So in the case of the pi 6, you get the 1/2. Okay, we got the 1/2. So that was 1. So suppose this is going to be this is going to be 1/2. So it's going to be our next point. Okay, so we start with this one and the next point here. Then we go to the pi 2 and the 0. This is a pi 2. So pi 2 and the 0 means you come back here. So this means you start from here. Okay, you go and then you come back. So this is going to be the graph of the function between 0 and pi half. Okay, so at 0 is equal to 1. Then it gets back to the 1/2, and then as we're getting closer to the pi half, you come back to the 0 again. Okay, so we continue 5 pi 6, 150. So let's get the 150 here. Okay, this is 60 degrees. So suppose this is going to be 5 pi 6. 5 pi 6, and over here that give you 11 pi 6. Okay, so at 5 pi 6 is 1/2, so it's going to be, this is it. And you get back to get to this point, and the 1/2 that you get. Okay, so it's going to be 1/2. At 5 pi 6, we get to the pi, it's going to be equal to 1. It's symmetric. So you continue and you get here. Okay, it's going to be symmetric. This is the version. Then 7 pi 6, we get the 3/2. 7 pi 6, this 7 pi 6, 3/2, 1.5. So this is going to be 3/2. So you come here. Okay, that's 7 pi 6. You go to 3 pi half and it's equal to 2. So you end up with a 2 here. Okay, so that would be 2. So this is 2. And then you continue 11 pi half 3/2. Okay, this is 11 pi 6. Okay, 11 pi 6. So you're going to pick this one over here. 3/2 is going to be 1.5. So that gives you 1.5. And then at 2 pi is 1. You go back to the 1. You go back to the 1. That's it. It's very important shape. We are going to use it for the arc length, and we may ask you to graph it. Now you know it, you don't have to give all this information really. This is going to be heart shape if you like, and we call it the cardioids. It's a very important graph, okay? It comes with a sine and a cosine, and you must know it. We are going to use it quite a lot, okay? So the explanation is graphs, okay, graphs of those form of polar equation, equations, okay, of the form, polar equation of the form r equal to the a times, the coefficient must be the same, plus or minus cosine of the data. Okay, you cannot have something like 2 plus 3 cosine. It must be, you know, if these numbers, it must be exactly, if there is an extra number, you should be able to factor it. And you must have 1 here. Okay, 1 plus or minus, and this one are equal to a times 1 plus or minus sine of the data. Okay, where a is of course positive, a is positive, are going to be called, okay, cardioid. Okay, cardioids or heart shapes. Okay, we call them cardioids. So a cardioid, okay, the cardioids contains, okay, contains the pole, the origin, okay, and is heart shape, and E is going to be, okay, heart shapes. So you should be able to identify it. Okay, identify it right away. And there is something that we are going to use in future. Okay, and you must know it. A parametric equation, we call it. Okay, we want to identify the coordinate of each point on the cardioid, if you like. So parametric equations. Okay, equations of okay, of cardioids are going to be this one. You see, x is r cosine of the data, or you have the r. So this can be, you know, for the one that we have. Okay, parametric cardioid, the one that I did. Okay, the equation of the cardioid r equal to the 1 minus sine of the data. The one that I have over here, x is r cosine of the data. You substitute for the r, because we are going to use this one for solving a couple of problems in future. So this is going to be the case. And y is equal to the r sine of the data. So we substitute for r, so that gives 1 minus sine of the data times sine of the data. I'm going to use it in a minute. Okay, just give you the idea. So get to know this graph. It's very important one. It's very important example. Okay, get to know it, and you will see when we get to the integrations, we are going to use the cardioid. So that's why we give you a preview. Okay, and there are quite a lot, but there's one more case that we are interested in for the application purposes. Okay, and the other one is a collection of flowers, if you like. We call them. They are very popular. There are different softwares you can check on internet for all of them. Check for cardioid, give you different softwares to graph it. Okay, again, you know, we are not going to be a face-to-face class, so you can use all these sources or resources on internet to get the information that you have. But it's nice to be able to identify it quickly. You see, look at this one, 2 cosine of the 2 data. Be careful. If this 2 is disappear, it's cosine of the data, this equation is a circle. Otherwise, you are going to have a bunch of flowers. We call them roses. okay, and they are very important to know. So if you want to graph this one, there are different ways to describe it of what would happen to this. You can get numbers, okay? Since you can use your calculator, I just give you some numbers and then I graph it, okay? So basically, if you look at it as a function, okay, in trigonometric function, and the period is, you know, that the period of the cosine is 0 and 2 pi. But since you have a coefficient over here, so 2 pi divided by 2, that gives you pi. So the period of this function, you see that's going to be the one. Note that that would be very useful for you. Just remind you the period of this function of a cosine of 2 data is from the tricks or from your pre-calculus class. So that gives you 2 pi over 2, which is equal to the pi. So this means this graph would would repeat itself, you know, in the xy coordinate, of course. It repeated yourself in the pi. If you are going to be in xy coordinates, the way we graph it in trig function, not this one. Okay, I'll just continue with this one so that you can see what I'm talking about. You see, if this given to you in pre-calculus class, and if you want to graph it, look at this one. If I have this one in pre-calculus, sorry, cosine, it's not bad to give you an idea. Okay, that give you 2 cosine of the 2x in pre-calculus or the xy coordinates. So what we do, we identify the period. You know that we divide the period into 4, so that give you pi 4. Okay, then this is going to be the graph of the function right away. It's the way we do it in pre-calculus. So the period is pi, is 0 to pi. We divide to 4 parts. Each part is going to be pi 4, you see. 4 parts. So this is the pi 4. Pi 4 and pi 4, this is the pi half. Another pi 4 is going to be 3 pi 4 and the pi. So the range of the function is 2 and -2. So we go up 2 and we go down -2. Remember, it's a cosine. The cosine starts from the top or the bottom, depends whether it's a positive or negative. If it's going to be the sine, you start from the origin. So this is start from the top. It's going down at the pi 4 to the intercepts. Then you go to the -2, which is the minimum. Then you go to the intercepts and you end up with the maximum here. So this is going to be the graph, the way we take it into there, okay. You see, this is going to be the graph of the function. Of course, if you think about it in the xy coordinates. Okay, but give you some idea of what's going to be the situation for this graph when you take it into the polar coordinates. You see, this graph, we divide into 4 parts. So the 4 parts is going to be here, you see, between 0 and pi 4. Then between the pi 4 and the pi half and the 3 pi 4, and the 3 pi 4 and the pi. So 1, 2, 3, 4 parts, as we do for all these graphs. So that will help you to classify it in this, you know, in this format that you're going to have. Okay, so I give you now so that would be very helpful to remember it, because we need this a couple of these ideas. So getting back to the original one, which is the data, and this is the R, which is 2 cosine of the 2 data. Quickly, you can get this information from here, that if you put the x equal to the 0, see, this is 2. So that gives you quickly 2. If you pick data equal to the pi 4, this would be 0. And if you pick the pi half, you can substitute if you like, but this is here. So that gives you okay, that gives you a negative 2. Okay, so that should give you one portion of your graph, and then you continue to get, to get to the other parts if you like. Okay, so that take you to the negative pi half, and then you can continue to get the the other part. The other part is going to be, if you pick the 3/4, that give you 0. Okay, and the pi that give you a 2. Okay, and in between you can pick more points if you like, but eventually this is going to be the graph of these type of functions. If you pick more points if you like, but I'm going to do it. Okay, so the crucial part, that 4 parts that I have, you see I have one of them is going to be pi 4. So this is going to be pi 4. And over here is going to be, okay, I have the pi 4, and the pi 4 here, this is 180, and the pi 4 is going to be 225, which is going to be, I think it's a 5/4. It's going to be 5/4. Okay, so then I pick another one here. Okay, to give me another version. Okay, this is going to be another one. So this is it. I go to this is going to be the pi 4. This is going to be the pi half. This is going to be 3/4. Okay, that give me 3/4. And then I got the pi here. Okay, I got the pi here. And then I come back. Okay, so that would be 3/4. So if you pick some numbers and do it, this is going to be the shape of this graph. You see, at the 0 I have 2 here. Okay, so that give me 1, 2. So this is going to be 2. Then I pi 4, I get back to the 0. Okay, so this means this is 2. Then okay, this is going to be 2. Then I get back. You see, it's going to be one version. So if you continue, it's going to be another version. Then at pi 4, you get the -2. So this is going to be the one. You can pick more numbers. If you pick more numbers and use your calculator, this is going to be the shape that we are going to have. I just summarize it. So as you can see, it's going to be like a flower. Okay, and you get 4 petals. Okay, 1, 2, 3. You start with the cosine, which is 2. 2 times 2 is going to be 4. So it's going to be a bunch of flowers. If this number is going to be even, you multiply it up. You say double it up to get the number of the petals. If it's going to be an odd numbers, you get, you get the same number as is. Let me give you the general instruction, and then from time to time we may pick just the easy case so that we can see it. Okay, so this is a situation that we're going to have. The explanation is graphs of these equations, graphs of polar equations of the form, look at the form sine or cosine, of the form r equal to a times cosine of the n data, or r equal to the a sine of the n data. Okay, when a is positive, when a is positive and n is integer, n is an integer. These graphs are going to be called roses. Again, search on internet, online, you see all of them, roses. So it's a bunch of flowers if you like. Now, if n is even, as the one that we did, then you double it up to get the roses. Okay, n is even, then, okay, then what we are going to have, the rose, in this case, has 2n petals. Okay, and if n is odd, if n is odd, then the rose has n petals. Okay, so if you have the, as I did it over here, I have the cosine of the two data, I double it up, so I get 4 here. So if it's going to be cosine or sine, this is going to be the case that we're going to have. But if it's going to be even number, okay, if it's going to be even number, you double it up. Okay, if it's going to be odd number, then you have the same number of the petal that you have. I'm going to give you another one for the odd number so that you can see it. They are going to be important for integrations, and we need to know what is going to be, the boundary here, and so we get back to it. So let's give you one with the odd so that we can see it. Let's see for number 6. Suppose you have r equal to the sine of the 3 data. Okay, sine of the 3 data. Again, if you want to do it in the xy coordinates, it's important for you to know what's going to be the, okay, the crucial numbers that you are going to pick to get this one true. Okay, so it's just for your information. Note that the period of this function, okay, the period t is equal to the 2 pi third. You got the 2 pi third. Then if you divide it into 4 parts, you see divide into 4 parts is going to be 2 pi third times a quarter. And you simplify this, and that give you pi 6, which is important to know. So if you are going to be in the trig functions, and if you want to graph it, you got the period of a 2 pi third, which is 120 degrees. So this is going to be the 0, and this is going to be 2 pi third. We divide it into 4 parts again. You see, it's the way we do the calculus, pre-calculus. Each portion is pi 6. You see, it's going to be pi 6. Okay, pi 6, which is going to be 30 degrees. Another 30 degrees and 30 is going to be pi third. Another one that give you pi half. And the last one that give you 2 pi third. The range of the function is 1 and -1. So at most you go 1 and you go -1. So this is the sine. The graph of the sine starts from the origin, going to the maximum, going to the intercepts, going to the minimum, and the intercepts. So in the xy coordinate sense, this is going to be the graph of the sine. You see, this is the way you do it, in coordinate system. But you can get this information, bring it up into the polar form. So that would be useful for you. You see, in the polar form, this information can be evaluated, but just give you a shortcut. So that is what we need. You see, you find out that if you put the data 0, so that would be 0. If you put the data pi 6, you know that you are going to get 1 here. Okay, if you put the pi third, you are going to have a 0 here. And if you get the pi half, you are going to get the -1 here. Okay, and if you get to the last part of your period, which is a 2 pi third, okay, 2 pi third, you get the 0 here. Okay, so that would be useful to be able to graph it quickly. So the situation that you are going to have for this one, that you get that 3 pedal that we talk about it, you see this is going to be between 0 and pi 6, and then the pi 6 and the pi half. And the last one is going to be pi half and the 2 pi third. So these are when those crucial parts would coming. Again, you can use those graphing table or the one that we are going to be interested in, this one. Look at this one. That will help you quite a lot to graph these quickly. Okay, you can identify these numbers. So you have the pi 6, pi third, pi half. We can get this one first. Say this is a 30 degrees. Okay, so this is going to be 30 degrees. Okay, which is the pi 6. And then you have a 60 degrees. This is going to be the 60 degrees, which is pi third. Then this is going to be pi half. Okay, this is going to be pi half. Then we get to the 2 pi third, which is 120. And this is going to be 2 pi third. Okay. So the situation that you are going to have, you start with the 0, 0. This is 0, 0. So this is your point. Then we get to the pi 6 at 1. So you have to start from the 0, 0 and you end up here. You say this is going to be one version. Okay. Then we go through the pi third, you make it into the 0. So this would take you back. So that would be one pedal. Okay, I start with the 0, 0, the origin. Then in the pi 6, I get to the 1. So this is the origin, I connected to the 1. Then I pick the second point, which is going to be the pi third. In the case of the pi third, I get 0, so I get back to 0 here. Okay. And the next one give you the pi half. This is the pi half. In the case of the pi half, you get the -1. So you have to pick this number down here. Okay, so we get the -1. So that take you 1 here. And then when you go through the 2 pi third, it would be 0. So the situation is this one, you pick more and more numbers if you like, but these are going to be the 3 battles that you have. If you need more points, you can select some points, to get those numbers. So that would be exactly, it's consistent with the one that you have over here. Okay. So the first version that you get it really, this is the one, you see this is going to be the one that you have. And the other part is just coming with symmetry property. Okay. So they are symmetric. In future, we are going to find the area of these curves. We find the area of one of them, we multiply by 3. So we get back to this for the future considerations. Okay. So these are the important graph that we need for, these are going to be our tools, because we are going to talk about the arc length, area under the curve, okay, the arc length and the tangent line problem, 3 famous problems in calculus. So we are going to focus on these graphs, these equations. So you better have a look at it. Okay, I will post another one for you in a couple of days times. Okay, maybe by Sunday. So we get to those notion of the calculus. We try to do all of them, okay, so that we can give you, we give you a couple of questions of this on the final. Okay, so have a look at these and look at your book if you like, just to get a good feeling of this graph that we have. But then I start the calculus. The next one, we talk about the tangent line. You know that the slope of a tangent line is derivative of the function, but we have to put it in the form of the polar form. And then the arc length and the area and the curve. Okay, just have a look at this, refresh your memory from your pre-calculus course and the section of 10.3. So we get back to you. Okay, have a good one and take care. Let me know if you need anything.